or first write down the definition, then we will understand. It has been observed that it has been observed that material fails under fatigue loading. Material fails under fatigue loading at a stress value lower than that of yield strength of the material. This phenomena of decreased resistance against fluctuating loading, against fluctuating load is called fatigue, and failure is called fatigue failure. Failure is called fatigue failure. Okay. So होता क्या है, let us assume a bar. Let's say this is a bar. Okay, and this bar is made up of, let's say, ductile material. Okay, let us assume it is made up of mild steel, and mild steel yield strength in tension is, let's say, 300 megapascal. 300 megapascal. So when you will apply here load, means you actually apply stress. When you apply here load, means you are applying the stress. Yes or no? You are applying the stress. For static loading, if loading is static, then when this sigma t will reach equals to sigma yt, then failure will start, or you can say this will be the strength. Okay, or you can say failure will start beyond this. So when sigma t will be more than sigma by t, then failure will start. Yes or no? When static loading you are applying. But in case of fluctuating loading, means this P can be positive, negative. Alternating stress, let's say cyclic loading you are applying. So in this, failure will start a failure will occur at sigma t lesser than the sigma yt. Generally, at zero 0.9 of sigma yt, zero 0.9 of sigma yt, failure will start. Okay. Failure will start. So this will be the condition. So when stress value is very much less, but it is cyclic stress. Let's say if I give you a wire, है ना, एक metal wire, very thin wire. If a metal wire I give you and I ask you to break it by tension, it will be very hard for you. But same metal wire, if you will bend up and down many times like this, up and down many times like this, okay, with very less effort, with very less bending stress, yes or no? So after some time it will break down. After few cycles it will break down. Got the point or not? So when loading is static, strength of material is high. At higher value it will fail. But when loading is fluctuating, material will start failing at much below the stress, much below the stress, uh, which is the strength of material. Got the point or not? So this is the case. Now, this decreased resistance means decreased strength due to fluctuating load. This phenomena is called your fatigue. Fatigue happened. Fatigue happened. And the failure due to fatigue will be called your fatigue failure. Fatigue failure. Okay. So for this type of loading, fatigue loading, new strength will come in picture. That will be called your fatigue strength. Okay. So now write down here. Now write down here. Fatigue strength. Fatigue strength. Or it is also called endurance strength. So it is denoted by sigma E or sometime SE, endurance strength, like this. Okay. So first of all, you will write first point, it is not a material property. It is not a material property like sigma yt, है ना, sigma ut, etc. These are the material property. These depends only on material. Okay. But this is not a material property. अभी डिस्कस करते हैं कैसे. नेक्स्ट, it is defined as the maximum value of completely reverse or you can say cyclic stress that the material can sustain for unlimited number of cycle. Unlimited number of cycles without failure. Without failure. Next, vanadium V is added to steel to increase its endurance strength. To increase its endurance strength sigma I. Next, it depends upon various factors like first, size of the member. Second, surface finish. Third, reliability या अगला लिखो स्ट्रेस कंसंट्रेशन. स्ट्रेस कंसंट्रेशन. नेक्स्ट, reliability, etc. Okay, etc. Next, to represent the endurance strength, ascent diagrams are plotted. Ascent diagrams are plotted between log ten of fluctuating stress and log 10 of number of cycles. Log 10 of number of cycles. Next point, for ferrous materials or steels, Ascent curve becomes asymptotic after 10 to the power 6 cycles. Asymptotic after 10 to the power 6 cycles. Okay. For steel, member is assumed to sustain minimum 10 to the power 3 cycles. So curve starts from curve starts from 3 comma 0. Curve starts from 3 comma 0. ओके, तो अभी बात आगे स्टार्ट करते हैं. हमने बात की कि जब स्टैटिक लोडिंग लगता है, when loading is static, the stress value can go up to the equal of strength value. If it is ductile, it will go up to sigma yt. If it will be brittle, we know for brittle material, we compare with the sigma ut. Let's say sigma ut is 400. Then here sigma ut we will use. But when load is fluctuating at a stress much lower than the strength of the material, failure will start. So failure can start lesser than the strength value. Okay. Now, what is the fatigue strength then? Fatigue strength will be considered when there is fluctuating loading. Okay, because material will fail at very low stress. So this was very disastrous. Like MIG planes, आपके फेल करते हैं कि नहीं? बोलो. MIG planes फेल होते हैं बहुत ज़्यादा. इस पर पूरी मूवी भी बन गई थी अपना रंग दे बसंती. देखिए मूवी. So MIG planes were failing and the designers or scientists were not able to figure out कि ये कैसे फेल हो रहे हैं. So actually, if there is a shaft and there are bearings, है ना, bearings, and there is a rotor, so this rotor weight or load will be W static. But if it is rotating, then due to this load there will be bending. So this side will be the compression and this side will be the tension, and the point or material will be rotating like this. So each point of the material will feel sometime tensile stress, compressive, tensile, compressive like this. So nature of stress is actually cyclic. Load W here can be static, but the nature of stress in the material will be cyclic. सो हम एक बहुत छोटा सा W भी इस पर हैंग कर दे रहे हैं शाफ्ट पर. W इज वेरी लेसर देन द यील्ड स्ट्रेंथ. बट आफ्टर रनिंग फ्यू साइकिल्स, आफ्टर सम टाइम दिस शाफ्ट विल फेल एंड वी विल बी अमेज्ड दैट ये शाफ्ट फेल क्यों हो गई. हमने तो बहुत कम W लगाया था. बिकॉज हम ये भूल गए, because we forgot that this loading is not static loading. So material or shaft can fail at a very lower value of stress because this stress is cyclic stress, alternating stress. Got the point or not? So for this type of loading, we have to check new type of strength, means sigma I. Now what is this sigma I? First of all, this is not the material property. So this will not be a fixed value for any material. These are the material properties. Material properties means if I consider a bar like this is a smaller bar and this is a larger bar. Both are made up of, let's say, mild steel. So Here, let's say the sigma YT for mild steel is 300 megapascal. This is bar 1 and this is bar 2. So on the bar 1, failure will start at some load P1. At some load P1. And in second bar, failure will start at some load P2. But P1 by A1, its area is less. So P1 will be lesser than the P2. At both the load, failure will start. In first bar, when you apply the P1 load, the stress will be sigma 1. But the failure has started means the stress value equal to actually sigma YT means 300 it will reach. And for second bar, failure started at P2. So sigma 2 will be the stress, but sigma 2 will be also sigma YT, then failure will start. Got the point or not? So when there is less area, less load will be required for the failure. When there is more area, more load will be required for the failure. But in both the bars, stress will be same 300, 300. So because they are made up of same material, the stress value should reach in this sigma YT, only then failure will start, and here also sigma YT, then failure will start. So this sigma YT is actually your material property. बात समझ आई कि नहीं आई? It is not depending on the shape and size of the members. In both the members, failure will start only when this sigma 1 will reach sigma YT and when this sigma 2 will reach sigma YT. This is why it is called material property. समझ में आई ये बात? जय हिंद लिखो. Load can be different in both, but stresses will be equal in both. But stresses will be equal in both. That's why it is called material property. It is not depending on the dimension, area and length of the both bars, but it is depending on the material. Got the point or not? So it is not depending on the dimension or surface finish or reliability or whatever. That's why it is called material property. Okay. But this endurance strength is not the material property. Not the material property. Means for the same material, if there are two bars, sigma E1 will not be equal to sigma E2. Sigma E1 will not be equal to sigma E2. Let's say both are made up of mild steel. Okay. And here you are applying the fluctuating load P1. Let's say plus minus 5 किलो न्यूटन पर इस पे फेलियर स्टार्ट होगा. एंड हेयर P2 will be equal to let's say plus minus 10 kilo Newton, then failure will start. Completely reverse loading you will check. So for this material, for this member, material is same in both. Material is same in both. Material is same in both. Here, for the first bar, P1 by A1, okay, this will give you the value of fluctuating stress. Fluctuating stress, sigma F1, and this will give you the value of fluctuating stress in second bar. Okay. So for the first bar, let's say first you are applying only 1 kilonewton. Then your number of cycles can be more than 10 to the power 6. मतलब ये इस स्ट्रेस पर कभी टूटेगा ही नहीं. If you increase the value 2 kilonewton, again the number of cycles are more than 10 to the power 6. Very high number of cycles, so these will be considered like infinite cycle. If you increase the value plus minus 3 kilonewton, again the number of cycles you can go more than 10 to power 6. You are pulling, you are pushing, you are pulling, you are pushing. So these number of cycle can be more than 10 to power 6. So these are not the endurance strength. 4 kilonewton, again the number of cycle are more than 10 to the power 6. Okay. So for the first bar, let's say at 5 kilonewton, add the cycles 10 to the power 6 cycle. Complete होने पर this material will fail. This bar will fail. This bar will fail. Got the point or not? So the value of fluctuating stress, maximum value of fluctuating stress, completely reverse, at which the material can sustain infinite number of cycle, means at least 10 to the power 6 cycle. This will become the endurance strength of the first bar, not the material. So for the first bar, if sigma F1 will be equal to sigma E1. So sigma E1 will be for plus minus 5 kilonewton divided by the area. Got the point or not? Similarly, for the second bar, let's say first you are applying 1 kilonewton plus minus, more than 10 to the power 6 cycle it will go. 2 के लिए भी, 3 के लिए भी, like this. At the 10 kilonewton, it will just complete the 10 to power 6 cycle. If you will make it plus minus 10.1 kilonewton, the material will fail at the number of cycle less than 10 to the power 6. So this load will become the endurance strength load. So at this load upon area, this will become your fluctuating stress value, means sigma E2. And this sigma E1 and sigma E2 will not be equal. Sigma E1 and sigma E2 value will not be equal. Whether it is same material, even then sigma E1 and sigma E2 value will not be equal. So it is not a material property. बात समझ आई कि नहीं आई? Even in case you are considering two identical members, 1 and 3, maybe area is same, A3 equal to A1, but if surface finish is not same, This is very smooth surface, highly polished, and this having rough surface, then even sigma E1 and sigma E3 will not be equal. Why? Because fluctuating strength, endurance strength depend on surface finish also. Surface finish means if it is highly polished, then surface crack etc. will be very less here. But if other material where there are surface cracks like this, surface crack will, internal crack will raise the stress concentration zone. Yes or no? There will be stress concentration. And stress concentration due to fluctuating loading, they will be more prone to failure. So even if both are of same size, if surface finish is not same, which cannot be identical, yes or no? So for same material, same size, if surface finish is not equal, even then sigma E3 and sigma E2 will not, E1 will not be equal. Got the point or not? So right now I am explaining only first point. It is not a material property. It depends upon various factors like size, surface finish, stress concentration, reliability, etc. ये बात समझ आई तो जयंत लिखो फटाफट, राइट डाउन। Okay, so one student called me, Kamal Deep. He secured All India rank 3 in the ISRO. So he just called me to inform, sir आपसे पढ़े थे, so rank ये आई है. So I just asked him to send me message. चलिए, so so first point is clear. It is not a material property like sigma yt, sigma ut, etc. Sigma yt, sigma ut. This point is clear? Very good. Now come back. It is defined as the maximum value of completely reverse cyclic stress that the material can sustain for unlimited 10 to the power 6 number of cycles without failure. What does that mean? What does that mean? Look here. Let's say if this is the member, this member. So this member, let us suppose this member, let us suppose its sigma yt is equal to 400 megapascal. Okay, so this sigma yt is for static loading. But at a stress, fluctuating stress, 0.9 of sigma yt, the failure will start due to fluctuating loading. So let's say when you will apply 0.9 means 90% of this, and material will break down only by one cycle. एक बार आपने बेंड किया एंड रिवर्स, सो वन साइकिल कंप्लीटेड, हाफ एंड वन, आफ्टर वन साइकिल मटेरियल इज ब्रेक डाउन. So log of this, log 10 of this will be equal to log 10 of this. This is for one cycle only, one cycle. So on this axis you will plot log 10 sigma f, and on this axis you will plot log 10 n. This is sometime also write as log 10 s, fluctuating stress, sf also it can be written. So this is your Sn curve. Actually it is log 10s log 10n curve, but name is famous for Sn curve, so we call it Sn curve. So it is breakdown just by one cycle. So one cycle will be actually equal to what? Log 10n means log 10 1. This I can write like log 10 to the power 0. 10 to the power 0. Okay. So this is now becoming 10 to the power 0 means here it will be 1. So one cycle will be completed. So one cycle will be just nearby this, and this value will be, let's say, here. This value will be here and this value will be here. So graph will start from here. So at this stress, number of cycle is only 1. When you will decrease the value of stress, let's say value is of stress is this, then the number of cycle will increase. Number of cycle will be this much. If you again decrease the value of stress, number of cycle will increase. If you again decrease the value of stress, number of cycle will increase. Got the point or not? So when you are decreasing the value of cyclic stress, the number of cycles are increasing. So here, when number of cycles will be 10 to the power 6, so log of n means log 10 of 10 to the power 6, actually it will be 6. So here, let's say this is 5 and this is 6. So 1, 2, 3, 4, 5, 6. So on this axis 1, 2, 3, 4, 5, 6 will be written. Okay. This is 10 to the power 0. So this will be 10 to the power 0 means one cycle will be here. So this will be the stress value sigma f at which the material can complete 10 to the power 6 cycle. This is the maximum stress. Beyond this, the cycle will be less. So this is the maximum value of completely cyclic stress at which material will complete 10 to power 6 cycle. अगर आप इससे कम स्ट्रेस लगाएंगे then the curve will become straight line. So curve will come like this, and after 10 to power 6 cycle the curve will become asymptotic. Asymptotic मतलब horizontal. Means if you will apply this stress, number of cycles are less. If you apply this stress, number of cycles are little more. If you apply this stress, number of cycles are 10 to power 6. So this will become actually corresponding to sigma e. So this will be log 10 sigma e. So this will be the endurance strength. इससे कम स्ट्रेस अगर आप लगा रहे हैं, if you are applying the stress less than this, okay, let's say this stress you are applying, so always it will be like this. The number of cycle will be infinite. इससे कम कुछ भी आप लगाओगे, number of cycle will be always more than 10 to the power 6, means nearly infinite cycle the material will complete. Clear हुई बात? So here graph will start like this. At this point log 10.9 sigma yt, then it will come down. Okay, here in between there will be 3, 4, 5, and here it is 10 to power 6. After the 10 to the power 6, the curve will become asymptotic. The curve will become asymptotic. So the value of stress, completely reverse cycle, will be here. So this value here, let's say this is your sigma f1, this is sigma f2, this is sigma f3. Okay, so log 10 sigma f1, log 10 sigma f2, log 10 sigma f3, these values. So here this will be log sigma e value, this is stress. Okay, if stress will be less than that, the number of cycles will go automatically infinite. So this is called asymptotic. AS क्या स्पेलिंग है? asymptotic. क्लियर हुआ सभी को? जिसको क्लियर हो गया राइट डाउन जय हिंद और इसको ड्रॉ कर दो. और इसको ड्रॉ कर दो. सो दिस इज द ग्राफ फॉर फेरस मटेरियल्स, है ना? दिस इज द ग्राफ फॉर फेरस मटेरियल्स, या ये किसी के लिए भी आप लिख सकते हो. फेरस मटेरियल के लिए क्या होगा और स्टील के लिए क्या होगा? For the steel, what will happen? The curve will start from 3. Here it will be 3 comma 0. Here it is 0 comma 0. But in case of steel, it is assumed that 10 to the power 3 cycle तो complete कर लेगा at least. 10 to the power 3 cycle तो complete कर लेगा at least. So in case of steels, the curve start like this. The curve starts like this. Here it will be log 10.9 of sigma yt. This will be log 10 sigma F1. कोई फ्लक्चुएटिंग स्ट्रेस लगाया होगा आपने. This is F2. At F1, number of cycles are N1 and N1 cycle are 10 to the power 4, N2 cycle are 10 to the power 5. So at this, N1 is 10 to the power 4. At this, N is your 10 to the power 5. At this, N is 10 to the power 6. Here log 10 sigma E will be. Log 10 sigma E will be the case. So this is for ferrous material. So for the ferrous material, curve will start from 3 comma 0. Curve will start from 3 comma 0. ओके, क्लियर है यहां तक की बात. ओके, now to check the material will fail at which stress. To check the material will fail at which stress. अच्छा, ये इनकम्प्लीट रह गया, इसको कंप्लीट करो ज़रा. ये सिग्मा F1 होगा, तो इसके लिए सिग्मा E1, सिग्मा E2, but sigma E1 will not be equal to sigma E2. This is for 10 to power 6 cycles. This is for 10 to power 6 cycles.